Okay, so here we go. Let's look at these shadow problems. Again, remember with any problem regarding related rates, you always want to start off by drawing a picture and using Wiggy to help you solve and set up the related rates problems, okay? So here we go. Jump straight in. It says a street light is mounted at the top of a 15-foot pole. A man 6 feet tall walks away from the pole at a rate of 5 feet per second. So he has really long legs and he's able to take a step that big, okay? Every second, okay? I'm not able to. My rate would be maybe like 3 feet a second. But I have little legs, okay?
The goofy walk.
So maybe if I were 6 feet tall and had a really short upper body and really long legs, that would probably work out. Okay? But for now it's not happening. But anyways, just pretend that it's real. How fast is the shadow moving when he is 40 feet from the pole? So let's check this out. Ready? Let's draw a picture first, okay? So what would we draw first? What are you thinking? Let's draw the light post, right? So I'm going to draw the light post, and how tall is the light post?
15 feet.
15 feet. Okay, then we're going to draw what?
The
6 foot tall.
The man, and he's going to be somewhere over here, and he's what? 6 feet, right? Okay, and then what's going to happen?
A shadow.
It's going to create a shadow, and it'll form a little triangular picture like this, right? Okay, so where is this shadow?
On the black side.
Down here, right? So I'm going to make an S, and I'm not going to write it as ugly as those other ones. I'll just make it curvy like that. Okay? And what do you want to use for this? Because this is something different, right? That's like the distance from the man from the pole, right? So what would that be? Could we just use X? If we use D, you could use D. That's what the other class wanted me to use. But then when we get the derivative, it's going to be what? dd dt, right? And then that's going to be kind of weird. Yeah, so I'm going to use X, okay? Hi. Have a question?
Where else are you in this class? I couldn't do it. He was like 5 foot. He was like, it's 5 feet. I was like, I'm only 5 feet. I was like, but aren't you like 4 feet? And I was like, wait. I was like, but aren't you like 4 feet? I still need another issue. Because you got a lot of issues.
So then give me one. So me. The hater.
Put your face on this.
Alright, so we got our picture set up nice and pretty. Let's jump into it, okay? What are we trying to find? How fast is the shadow moving? So how fast is this whole thing moving? So ds over dt. When? When he is 40 feet from the pole. So what would that be? X equals 40 feet, right? Given? What are they giving us? The rate at which he's walking. So which one would that be? The M? We don't have any M's in our picture. X.
D distance. For velocity.
Is it going to be dx dt? Yes, right? Because what does x represent? The distance from the pole, and dx dt would be the rate at which he walks away from the pole, right? Okay, so dx dt equals what? 5 feet per second. Is that positive or negative? Positive, why? What's happening to that distance? It's increased. Are we good? Awesome, okay, so what's the equation that we need to use for this one? Pythagorean theorem? No, not Pythagorean theorem. Is there a straight up formula like area or something I can use? No, okay, so we need to make one up, exactly, okay? So in order to make one up, we have to go back to geometry and we need to set up a proportion. Okay, so we're going to set up a proportion using what? Similar figures, especially in this case triangles, right? So I have a triangle within another triangle, they are related to each other. Good? So So let's draw the bigger triangle. Okay, so that one has a height of 15, and what would the bottom be? Not 5, S. See, I gotta change it to a 3. Okay, and what would the other one be? 6 and S. Okay, so how could I set up an equation using those two? What would I have to do? Make a proportion which is one fraction equal to another. So you tell me how to write the fractions, because that's what I want to check that you know how to do. 15 over x plus s, we could do that, equals 6 over, not 5.
Sorry, my S looks like
S?
5, so.
Yeah, make your s like mine, curvy.
I'm trying.
Okay, cool.
So
So kind of like the example that I did right before we started, right? That simple geometry problem. Okay, except here we don't know x, okay? And the common mistake or the common thing that kids want to do is they want to put that 40 there already. You can't put that 40 there because that 40 is what? It's changing, right? So don't plug that 40 in. Alright, cool. So we end up with 15 S is equal to 6x plus 6s. Let's minus that 6s. And we end up with what? 9s is equal to 6x. Okay. So ultimately, we want to end up with ds dt, right? So why don't we just make this guy s equals? So when I get its derivative, it'll already be ds dt equals, right? So let's divide by 9. So now we know that s is equal to, what's 6 over 9 reduced to?
2 over 3.
2 over 3x. And now can I figure out what ds dt is using this equation that I figured out? Okay, so let's do it. Now we have to differentiate, right? So we'll get ds dt is equal to 2/3 dx dt, right? So that'll end up being 2/3 times what? 5. Now it's a 5. So 5 times 2 is what? 10 over 3. So it's just 10 over 3, and what will be my units? Feet per second. Did you pick the right one? Make sure you pick the one in this particular room. Yeah, see where it says fitter? Pick a different grade. That one, 228. That's why I was sending it somewhere else. Well, not sending it somewhere else, but it was printing to file. So it looks like saving. Alright, are we good? What do you think? Okay? Not too bad? Yeah? Okay, so these problems are not going to be as straightforward as the other ones where there was just a formula that you already knew and that you could use. Here you have to sometimes come up with the equation using what's given. Right? The other question that they ask regarding shadow problems is this one right here. Okay, they might also ask how fast is the what? Is the tip of the shadow moving when he is 40 feet from the pole? Okay, so this one is talking about the rate at which the shadow or the length of the shadow is changing, right? Okay, that's telling you how the whole shadow is moving, right? And the shadow is actually changing in size as I move away from the street poles, right? What the next one is asking is the rate of change of just the what? Of the tip of that shadow. So the shadow will always have a tip. I want to know how that tip is moving. You understand? How do I figure out where the tip is? What do I have to do? Saying that it doesn't match. Because what you're printing is probably smaller than what you're.
But I was laughing at your face because you were like, you said She's so weird. No, I was like, that's not funny. That's I know that you're like, I'll take it.
You're trying to print it on a
I saw him. It made me laugh.
How is you?
So mean.
Like copy and paste it to a regular sheet of paper, so that way it'll print on a whole sheet and then you cut it out. Alright, so how would I figure out where the tip of the shadow is?
Oh yeah, I got it.
What would I have to add? I would have to add what? The S, which is this distance, plus what? The X, right? So to figure out where the tip of the shadow is in relation to the pole, I have to add X plus S, right? Okay, so you want to define your variable so that way whoever is grading it understands what it is that you're talking about. So I'm going to say that T is equal to the tip of the shadow. Okay? What are we trying to find? How fast is the tip moving? D capital T over D little t, right? When? So when x equals 40, given dx dt equals 5 feet per second, right? Okay. And what's the equation that we're going to use? How are we going to figure out the tip? Where is the tip at? X plus what? S. Oh, so do we have an equation? All right. So can we differentiate it?
X is.
So dt over little dt. It says Texas?
Yeah, look at it.
Awesome.
Can you see?
It's the greatest equation ever.
I know.
So we end up with dx over dt plus ds over dt. Okay, and we know those two rates, so plug them in to figure out what we get.
We got it, but never mind.
You said it every day.
Can you go to the print shop and cancel that print?
Calm down.
Previous
And on
one.
the weekends it looks like.
It's at the bottom. There should be a little printer on the right hand corner.
It does.
Calm
Copy
down.
here. Shake it off and go back again. Let it on your over like this. Because your hair grows different if you cut it off. Maybe I cut it off. And not
It's not letting me cancel it. Right click on it. Cancel down. Doesn't let me cancel. Should we put paper in here? Maybe it'll just print it.
Yes, these are ones with 5 feet. Yes, is 10 over 3.
Alright, so what's dx dt?
Five.
Yeah,
I
you
think it's going on.
Yes, that's what you want. 15 plus 10.
What's dx dt, guys? 5. What's ds dt? 10 over 3. And when we add those, what do we get? 25 over 3.
No, what you say?
Okay? And what would the units be for that? Feet per second. Are we good? What if they just asked this question down here? Would I still have to do part A? Yes. Okay, and that's more than likely what's going to happen. Okay, they're not going to ask you part A. I'm asking you part A because I'm taking you baby steps through answering ultimately part B. Okay, but on the test, they might straight up go to this one. Okay, and you're gonna have to know that in order to do this one, you have to do that one first. Okay? What would be another way that they could say the end, or I mean the tip of the shadow? What would be another way in the word problem for them to say find the tip of the shadow? Oh, the end of the shadow. Yeah, some of you were listening. I kind of gave it away. Okay? So another way that they could represent the problem would be to ask how the end of the shadow is moving or changing, right? So if they say the end of the shadow, it also means the what? The tip of the shadow. Okay? So let's try another one. Or we don't need to do another example. You're good. Want to do another one?
We're down for another
one.
one.
The same style, okay? Alright, so it says, on a dark night, a thin man, 6 feet tall, walks away from a lamppost that's 24 feet high.
Why couldn't you fast?
At a rate of 5 feet per minute. How fast is the shadow lengthening when he is 10 feet from the pole? So again, first thing we should do is draw what? Draw a picture. How big is the pole?
24.
24 feet. How tall is the thin man? 6 feet.